Okay, so this week's e-learning lesson, starting on April 13th and going to the 17th, is about two gas laws. The first is Boyles' law, and the second is Charles' law. We will discuss each law, do a sample problem, and then you'll be prepared for the assignment that you're asked to do this week. Boyles' law is based on when the volume of an enclosed gas is increased, then the pressure is decreased. Okay, so this is inversely related, right? It's an inverse relationship. It's an S. And that's an R. And when the volume is decreased, the pressure is increased. Now, the one thing that has to happen is our temperature has to be constant. Okay, so with our temperature constant, it's an inverse relationship between volume and pressure. As one increases, the other decreases. So an example of this would be, let's say you are filling up a tire, and you add compressed air. Okay, so as you put more and more air into a tire, you're forcing the gas molecules to get packed together. When you do that, you reduce the volume, all right, while the pressure increases. So reduce the volume by increasing the pressure. And so that's just an example of Boyle's law in everyday life. The formula for this is, usually we're talking about a situation where we have an initial, okay? So we have an initial pressure and volume, P1 and V1. That's where we start at. Then at the end, we're going to be given either a final pressure or a final volume. And when we're given that, then we use that information to solve. So it turns into a math problem. So if you know 3 of the 4, we can calculate the 4th. And here's an example of what a Boyle's law problem would look like. So we have 22.5 liters of nitrogen at 748 millimeters of mercury. It's compressed, so the pressure is decreased to 725 millimeters mercury. The temperature stays constant. We want to know what the new volume is. This is, of course, a Boyle's law problem. So P1 times V1 equals P2 times V2. I'm starting with here with this liter, so this is V1. This is my pressure I start with, so that's P1. And then this is my pressure I end with, P2. So I know P1, I know V1, and I know P2. I'm going to have to solve for V2. So now I just substitute in. So I take 22.5 and put that in for V1, or for V1. For P1, I put 748, and that's going to equal 725 times V2. So again, I'm solving for V2. So I'll take 22.5 times 748, and I get 16,830. And that's going to equal 725 times V2. If I divide both sides by 725, I get V2 is going to be equal to, and I have 3 sig figs here, 3 sig figs here, 3 sig figs here. So my answer will have 3 sig figs. 23.2 liters. I know it's liters because I had liters to start with volume. And so that's how I know what will happen. So if I decrease the pressure, my volume increases. Okay? So that's an example of a Boyle's law problem. The other gas law is Charles's law, but to do that, we have to be able to convert temperatures. So let's say we have our temperature in Celsius, which is mostly what we measure. In gas laws, we use Kelvin, which means we won't get negative numbers because Kelvin is 273. So knowing that, we can go convert from Celsius to Kelvin, and this is probably the conversion you'll do the most. You can always go back from Kelvin to Celsius if you want to make a comparison by subtracting 273, but this is the main conversion that we want to think about, okay? So examples of that. Let's say we have 40 degrees Celsius and we want to convert it to Kelvin. Essentially, I just take 40 plus 273, and I get 313 Kelvin. Now, if I want to go from Kelvin to Celsius, I would take 40 minus 273, and then that would give me negative 233 Celsius. That's pretty cold. So you can see as Kelvin gets down to 0, which is what we call absolute 0, And that's something maybe we'll talk about on a different day, but absolute zero is the coldest anything can get. But you can see 313, negative 273 to go from Celsius to Kelvin. We add 273 to go from Kelvin to Celsius. We subtract 273. So it's that simple. Charles's law is when the temperature of a gas increases, the volume of the gas also increases. And when the temperature of the gas decreases, the volume of the gas also decreases. This is a direct relationship. And this occurs when the pressure is kept constant. Okay, so the pressure is constant. So here's something that you may or may not know, but let's say you have a ping pong ball and you really smack it hard, right, and it becomes dented. When we do that, if we want to increase the volume of the gas inside of the ping pong ball to get it back into shape, to restore the roundness, we get warm water, and then we just set the ball inside, and what will happen is it will expand, it will heat up, and we will increase the volume of the ball, which then will expand it, and the ball will become round again. So that's an example of using Charles's law to your advantage. And this is something that you can test yourself. Take a ping pong ball, give it a dent or a wiffle ball or something like that that you have around. That's an enclosed container, not the wiffle ball with the holes in it. But then set it into some hot water if it's dented, and it should pop back out. So Charles's law of the direct relationship between temperature and volume. So we show it this way. Same connotations. V is volume, T is temperature. The 1's are initial, volume and temperature, while the 2's are final, volume and temperature. And again, if we know 3 of the 4, we can calculate the 4th. And so I'll show you an example of a Charles law problem. We want to know the temperature when 6 liters at 20 degrees Celsius is compressed to 4 liters. Now, first thing we want to do is convert all temperature to Kelvin. All right, so temperature has to be in Kelvin. So I take my 20 plus 273, and I get 293 Kelvin. So that's this temperature now is here, okay? So 6 liters is V1, 20 degrees Celsius is T1, or 293 Kelvin is T1, and then 4 liters is V2. I don't know what this is doing, but I'm going to move it down to here. Hopefully we're still copying, but we'll see. All right, so I solve this then, and I say, all right, so I got 6, I take V1 over T1 is equal to V2 over T2. So V1 is 6. T1 is 293, because I want it to be in Kelvin, over V2, which is 4.00 over T2. I cross multiply this. So I take 6 times T2, which is 6.00 T2. And I take 293 times 4. 293 times 4, when I do that math, gives me 1172. And keeping my 6 T2 here, I then divide both sides by 6, and I get T2 to be, and I'm going to use 3 sig figs here, 195 Kelvin. Now if I want it in Celsius, I just subtract 273, and that's about negative 78 degrees Celsius. And so volume goes down, temperature goes down, and that's what we expect to have happen. Hopefully you're not having any issues here. If you are, please get in touch with me. I can walk through some other problems with you. We can talk about the homework assignment, whatever you need. Thanks for listening, and good luck.